Hi everyone, this is Miss Longley and we are going to be continuing on with Osmosis Part 2. We're going to be looking at different scenarios using osmosis and learning about the three types of solutions. So we're going to walk through an example first, and what I would like you to do is just watch for now. If you would like to have this example in your packet or your notebook, you can always come back to this point and rewatch it. But the first part is it's important to just watch it all the way through so you can get the idea of how osmosis works. Again, this is really challenging information, so feel free to pause the video at any point, but I would definitely just watch it the first time around and then come back and sketch it out yourself. So let's begin. All right, so we're using the example of when you have a bowl of strawberries and you place sugar on them, it makes the water come out. Super yummy, but why does that happen? So here is the reasoning why water suddenly appears in that bowl of strawberries. We're going to figure that out using the process of osmosis. So let's pretend that this is a typical cell. Inside of this cell, we are using this to represent a strawberry cell. So we're going to be using water molecules. So where is there more water? Well, we have some water on the outside, and this is representing the moisture in the air. We also have water on the inside of the cell too. Remember, this is representing the molecules of the cytoplasm. So that's where we have more water is on the inside of the cell. There's some water on the outside. So now we are putting sugar in this scenario. The sugar is on the outside of the cells. Remember, you're not injecting the sugar anywhere. You're just putting them on top of the strawberries. So these little pink dots that you see, these are representing the sugar solute molecules. So things to keep note of. Solutes, like the sugar, will not cross the cell membrane. Only water will. Again, we're looking at the process of osmosis, which is only water molecules moving across. So just visualizing right here with this picture, which way do you think water will move? Will the water go into the cell or will the water leave the cell? Let's find out. So here we have a high water concentration inside the cell, and the water will actually leave because remember, water wants to go from an area of high concentration to an area of low concentration. A little rhyming trick to help you remember this is high to low is the way we go. That's where water is going to want to go. So it's going to want to leave an area of high water concentration to an area of low water concentration. Notice that the water went to where there's more solute. So not only did water go from high to low, but it also went to an area of high concentration of solute. Remember, the sugar's on the outside of these strawberry cells. So what do you think will happen to the cell as a result of the water leaving the cell? Do you think it will shrink in size, stay the same, or swell? Let's find out. So the cell shrinks. That's because all of the water has left. So when you look at this picture of strawberries after sitting in sugar for so long, all of that water is actually leaving the strawberry cells, and that's why you're seeing water in the bowl. So the sugar never entered the cell. Only water molecules have moved out. As a result, the strawberries are going to become very shrunk and shriveled, and that's because all the water, the cytoplasm, has left the cell. Okay, so we're going to hit pause here and kind of start over again. So here's the same scenario, but the water molecules are not seen. We actually removed them from this picture. So all you're seeing is actually the solute of the sugar that we added to the outside of these strawberry cells. So sometimes there might be some scenarios where the pictures are going to assume you know that the blank space is representing the water molecules. They may not always be shown. So we only can look at the solute and just keep in mind, where would the water typically be? All right, so again, we're starting from the beginning. We know water is here, we're just not seeing it, but we can see that there's a lot of sugar solute on the outside of the cell. So just assume that water is here, it's just that blank space. So even though we don't know exactly where the water molecules are, we can see that there's a high concentration of solute on the outside of the cell. So remember, water moves from high to low concentration, but if you can't see the water molecules, then know that they will move to where there is the most solute. So in this case, the most solute is on the outside of the cell. So the water wants to dilute the sugar. It wants to bring that cell to equilibrium. In order to do that, the water's got to leave and head to the outside. Just like this. So as a result, because water is leaving the cell is going to shrink. So same process, we just removed the water molecules. We couldn't see them, even though we know that they're there. All right, so at this point, you can go ahead and start this video over again so you can see this example. If you'd like to put it in your page 2 of your packet, there's a blank space there, or if you'd like to put it in your notebook. I'm going to keep moving forward, but feel free to come back to this point. Okay, so now you're going to try the same thing, but you are going to be identifying the 3 types of solutions due to the process of osmosis. So continuing on page 10, you're going to be looking at these pictures here. It'll give you this scenario, and then it'll give you a picture, and it'll tell you what kind of solution that cell is currently in. Remember, the dots will not cross the membrane. So these dots that you see are actually solute. The blank space is actually the water. So you're going to have to imagine where the water would be, or think about where does water want to go in terms of the most solute. Using this information, you're going to be filling out this table, so identifying the terms and thinking about where does water move. Will this shrink the cell, swell, or stay the same? So go ahead and do that right now. And then you can unpause the video and we'll go through the answers together. All right, so let's review these. Hopefully you had a chance to look through them and figure them out. I'm going to move my profile picture over here. All right, so the first one we're going to be looking at is a scenario where a healthy cell is in the ideal situation. So the cell is in an isotonic solution. Keep in mind these dots are representing solute. They are not going to be moving. The blank space is representing the water molecules, which are going to be moving. So based on this term and looking through these definitions, hopefully you're able to figure out that the definition is the solute concentration outside of the cell is equal to the inside of the cell. So what does that mean? It means that water is entering the cell at the same rate that it is exiting the cell. Remember, once water molecules are at equilibrium, they don't stop moving. They're constantly moving around. They're just at equilibrium and moving at the same rate. So as a result, water is leaving and enters the cell equally. There is going to be no change in that cell. This is what we call like the happy version of the cell, or in terms of like the Goldilocks story, this is just right. We want our cells to be isotonic in that kind of solution. All right, here's the next one, the scenario. Human brain cell after drinking too much water. The cell is in a hypotonic solution. So here we can see that there are a lot of solute inside the cell and there's fewer solute on the outside. So figuring out what definition that term goes to, we're looking at this bottom one down here. So hypotonic, the solute concentration outside of the cell, is less than on the inside. Water is going to be entering the cell. Remember, water goes from high to low, but also water is going to where the most solute is present. So in this case, water is moving inside because that is where the most solute is. A nice trick to help you remember hypotonic. As a result, because that water is moving in, the cell is going to get bigger and bigger. So here's a little memory trick to help you remember hypotonic. When you say hypotonic, when you say it hypotonic, if you enunciate the O part, you're kind of representing a cell swelling. So hypotonic, the cell is going to swell. That's what a hypotonic solution is. So hypotonic. I know it looks kind of weird, but it works. All right, here's the last one. So cucumber covered in salt or strawberry covered in sugar, like the example that we just went through. This cell is in hypertonic solution. So we notice that there is more solute on the outside of the cell and less solute on the inside. Can't see where water is, but we can kind of visualize where water would be in the blank space. So last definition that we have to match, the solute concentration outside of the cell is greater than the inside of the cell. So where's water going to go? Remember, water goes to where the most solute is. So in this situation, it's on the outside. So water is going to be moving out of the cell. So water leaves the cell, therefore the cell is going to shrink in size. It's going to shrivel up. So way to remember hypertonic, the cell is going to shrink. When you say hypertonic, your lips get really tight together if you enunciate it a little bit more. So hypertonic, it shrinks. The cell is going to shrink because water has left the cell. All right, so let's do a quick little recap on these three types of osmotic solutions. So the first one we have is hypotonic. Remember, hypotonic. Water is moving in. So the cell is going to swell and burst. Not good. We do not want our cells to do that. So the water will enter the cell because there's a lot of solute in there. It wants to dilute it, bring it to equilibrium. Isotonic, water's leaving the cell and entering the cell at the same time. I don't really have a good memory trick for that one, but just because the word starts with the letter I, hopefully you know that that one's the one that's equalized. So water is entering and leaving at the same rate equally. The cell will stay the same size. This is a happy cell. We want our cells to be in an isotonic solution. All right, the last one, hypertonic. Hypertonic. Your lips are getting really tight together. That means that the cell is shrinking. That means that water has left the cell. So water will leave the cell will shrink. Also not good. We don't want our cells to shrink and shrivel up. We want them to stay hydrated. Make sure you're drinking some water today. So the ideal situation is isotonic. We don't want hypotonic. Hypotonic, cells getting big. We also don't want hypertonic, cells shrinking. All right, so that is the end of our screencast. Feel free to watch this again. This is tough stuff. So it's going to take some time to process, but with some practice, hopefully you will understand it and you'll be able to figure out any scenario that involves osmosis. Thank you for watching.